Hello. Today we are going to go over Partnership for Assessment of Readiness for College and Careers, otherwise known as PARCC, math practice items. Before we go into those items for the lesson today, I wanted to share some testing dates. The first testing date is going to be between the 9th and 27th of March. The second testing date will be May 9th through the 12th. So we will be getting back with you about exactly what days you will need to be there, but just plan on having those dates open for now in case we have some testing for you during that time. Objectives. We are going to go to the PARCC website to practice test items and to view the types of sample problems. Using their technology, you will see on the PARCC test to hopefully get you a little more acquainted with the format. After this lesson, you will be expected to take the quiz in Edmodo. This first question is a sample item from the PARCC website. Anyone can view those questions after this lesson. Mila's swimming pool contains 16,000 gallons of water when it is full. On Thursday, her pool was only partially full. On Friday, Mila decided to fill her pool completely using a hose that flowed at a rate of 10 gallons per minute. It took her 5 hours to completely fill her pool. So as you can see, there's two parts to this question. So the first thing we want to make note of is that it says there were 16,000 gallons of water when it is full. Okay, and that was on Friday. On Thursday, her pool was only partially full. And on Friday, Mila decided to fill her pool completely using a hose that flowed at a rate of 10 gallons per minute. So those are the keys that are going to help you solve this problem. 10 gallons per minute is the rate we're going to use to help us solve this problem. Type a number into each box to complete the sentences. So you can see this is just a type of fill-in-the-blank question. Before Mila started filling the pool, there were how many gallons of water in the pool? Okay. And part 2 of part A is the rate at which water is being added to the pool is how many gallons per hour. So you can see that they gave us the rate as a rate per minute. So we're going to talk about how to convert rates from minutes to hours. Before we do that, we're going to solve this first problem by figuring out how many gallons it took Mila, or how many gallons she would have added to the pool over 5 hours. So if the rate is 10 gallons per minute, and it took her 5 hours to completely fill a pool, how many gallons is that? So you might first want to convert minutes, or the number of hours, to minutes, since we already had a rate in minutes. Another way of writing a rate is just by setting up an equation. So if she can fill 10 gallons of water per minute, there are 300 minutes in 5 hours, then what would make this statement true? So we see that 1 times 300 is equal to 300. So we would have to multiply the numerator by the same number in order for these two ratios to stay equivalent. So therefore, 300 times 10 would give you 3,000 gallons in 300 minutes or 5 hours. So now we know how much she filled the water to get back up to 16,000. So how much did she have in her pool before she started to fill the pool. If the whole entire pool will contain 16,000 gallons of water. So I'm going to let you guys solve that one on your own. The next part of the question simply is asking you for how many gallons per hour this hose fills. So we have an original rate of 10 gallons per minute. How many minutes are in an hour? We're simply going to multiply both numerator and denominator by 60 to convert it to an hour. So to convert minutes to hours, we have to multiply it by 60. 60 minutes equals an hour, and then 60 times 10 is going to give us 6,000. So we have 6,000 gallons per hour. We're going to use this next rate to help us on part B. Part B asks, on the coordinate grid provided, graph a linear function that represents the number of gallons of water in Mila's pool given the amount of time in minutes she spent filling her pool on Friday. So we know our rate is in minutes, 10 gallons per minute. And we are going to just want to fill in 2 points is all we need in order to have this line drawn for us. So all we need are 2 points on the line, and the line automatically is drawn through those points. You can try that on the practice test yourself. So we just simply have to solve a few problems here. I chose point 25, so in 25 minutes, how many gallons would she fill? So if we multiply this by 25, and this by 25, we get 250. So the horizontal axis represents the number of minutes. So my x is 25, and the vertical axis represents the number of gallons filled. So we have a point here at 25, 250, which you can see is halfway between the 0 and 500 interval. I also solved for one more at 100. At 100, there were 1,000 gallons. So after locating those 2 points, the graph of the line was drawn automatically for you. Let's take a look at another problem here. This one is a drag and drop question. Let's go ahead and take a look at the question together. Sam uses 1-inch frames for pictures for which the length is 2 inches longer than the width as shown. The area of the frame for a picture that is 8 inches wide is given by, x inches wide is given by the expression quantity x plus 4 times quantity x plus 2 minus quantity x plus 2 times x. What is all of that saying? Well, we're going to represent just the length of the picture alone. Here's the picture, length and width. So the photograph of the picture would go right there. And then here's the actual frame. The frame is 2 inches, or it's a 1-inch frame. So we're going to have 1 inch around each of these corners. So 1 inch here, 1 inch here, here, and here. So the length of the picture is 2 inches wider than the width. So x represents the width of the picture. The length of the picture then can be represented as x, or the width, plus 2. Okay, it's 2 inches bigger than the width. The length of the actual frame is going to be 2 more inches than that. So we have 1 more inch here, 1 more inch here for the total length of this picture. So we already have x plus 2 represented by this length of the picture plus another 2 inches. So for the length of the actual frame, we're going to write that as x plus 2 plus 2, or x plus 4. Okay, so that's the length of the frame. How about the width? So the width of the picture, again, we're going to have the same thing, but this time we're only starting with x. X is the length, this length here of the width of the photograph or picture, and then the width of the frame is going to be another 2 inches. So we have another 2 inches here, and another 2 inches here, or sorry, 1 inch. So another 2 inches added to the total width. So width of the frame is represented here, x plus 1 plus 1, or x plus 2. So we have the length of our frame represented, the length of our picture. We have the length of the width of our frame here represented by x plus 2, and the width of our picture is x. Now, if you wanted to find the actual area of just the frame, just this brown region here, then you could take the entire, remember, length times width equals area for a rectangle. So you could pretend you're taking the entire area of this rectangle, pretending this rectangle itself, we want the whole entire area there. We could do that, and then simply subtract out the area of the picture. Okay, so the area of the picture, remember, was given by x plus 2 times x. So you're going to subtract out the area of that picture in order to get just, let's see, the area of the frame. So let me just go ahead and we're going to black out this part by subtracting the area of just the picture from the total area of that rectangle to get just this area of the rectangle. So the area of the frame for a picture that is x inches wide is given by the expression, and here you have total area x plus 4 times x plus 2 minus this black region, the area of the photograph, x plus 2 times minus x plus 2 times x. All right, so hopefully you understood how we came up with all of these expressions to represent different widths and lengths of the picture and frame. So the next part of the question is for you to identify these parts of the expression. And this is a drag and drop problem. So here you could identify the length of the picture alone. The picture alone, or the photograph, is here. It's 2 inches longer than the width. The width is given by x, so x plus 2 would be the length of the photograph. So we would simply drag this one over to the right spot. For each of these, you would drag one of these over to the right spot. So that one is an example of a drag and drop. Well, those are just a few items which I wanted to share with you from the PARCC Math sample items. I hope that you enjoyed it. Now you may go in and take your quiz. I hope you have a great day. Thank you.